Recently, I've been diving into the topic of security for websites, and I found this very interesting article regarding WordPress websites. And apparently, only 15% of them pass basic security measures. That's another way of saying that 85% of them fail. To take matters further, there are certain rules when it comes to accessing websites, which are set by developers called security headers. And they actually affect SEO rankings very much so. For the basic reason that whenever you visit a website and that website is not secure, you're likely to bounce, which means you're going to leave that website, right? Not only that, the crawlers themselves, such as what Google uses to crawl through the web and see what kind of websites are out there in their sitemap, will actually end up picking up on insecure headers. And as a result, they will not place trust on that website and you will not be ranked. So this is very important. It turns out there is an amazing website called Security Headers by Sneak, and I inserted there one of my products, lanai.com, in which I saw that I actually have an improper implementation of my content security policy and my permissions policy. So what better way than to use n8n to actually automate the process of discovery of issues on a security header basis and take that piece of information and pre-process it using an LLM to give you a plan of attack. So in this video, we'll be going over this flow, and it's going to be done in a matter of several minutes. And finally, we're going to use an AI coded editor, in my case, Claude Code, to take this information and to restore my website's security policies to a good standing. Before we go into the workflow automation itself, let's talk a bit about the problem so that we can really drive in the motivation. And you should think of a school building as an analogy here. So you have the school classrooms, which are like web pages. You have the hallways, which are like the navigation system. And then you have the school students themselves, which are your users. Okay. So you have like a set of rules, right? When it comes to like managing the school and the conduct, right? And you have like some security guards and such. Otherwise, things run amok, right? And it would be an insecure environment. And this really is the reason behind security headers. Like they control really what happens in these web pages between the users and the web page itself, but also with the network that is providing that bandwidth for accessing the web page. So the first issue that I had was the content security policy. And you should think of it as the way in which you can have certain malicious scripts sneak into a web page. It's like the way where like you can take like the login information. Somebody can access your account. You can inject maybe a false payment form and get like somebody's credit card information. You can also track users. And that's why you should have like CSP protection. The second issue at hand is the permissions policy. And you should think of it as the school rules for what kind of devices people can bring to the school. So when you're like looking at the web page, and, you have the ability sometimes of giving camera access or microphone access, right? And this is like a device that the web page has access to. And you should be able to control that. Otherwise, somebody may be, through their, again, malicious website, get access to your device. Now, let's go through the automation itself. This is as I said before, all-encompassing automation that allows you to do three basic things. You perform the security scan. You save the results in that table, specifically a cheat sheet that I created right here. In the description, you can see the template as well and use it for your own purposes. And then finally, you send an email report straight to you. This is using a Gmail account. This is serving the majority of people, but it can be changed to use other email service providers as well. So let's go ahead and run this node, or rather this workflow over here, starting with the form input node. And the thing we're going to do is just go ahead and execute this workflow, and it's going to open up a new page with the form. And I'm going to say, okay, the website I want to check is lanai.com, and it should give me the same report as it did earlier. And I want to receive this report in my lanai.com email. So done. And you can see went ahead and it ran through. And let me just show you here what's happening. It does a GET request, which is another way of saying, I'm using a robot to visit the website itself. And it gets the data, which is the HTML page, but then the headers that come with every HTML page. And these are what we're looking at specifically to assess whether we pass the test, right? And as you will see over here, we have a report that shows I got a grade of B and the CSP is missing, and I need to address this, right? And here's the email. You can see that I'm missing my CSP and my permissions policy, and it explains to you what these are, and then eventually gives you some additional information over here. And this really is the juice of it all, because you here have a, let's call it like a high level plan of action for addressing this. And we're going to go ahead and then copy paste this. I'm just going to go ahead and do this right now and move it over to my website. Now, as I said earlier in this particular video, the majority of people that are using WordPress probably have these issues. So I made also a clause here for WordPress itself, because it's a drag and drop type of interface. You need to go in there and actually find the right place to address these headers. And it's very different from what I do myself, which is use Vercel, and I build a web page from the ground up and rely on Vercel's, let's call it, additional services in terms of providing security to my website. And it does it actually quite well. So we're here in my local environment, specifically my ID, which means Integrated Development Environment. And for those of you who are familiar with it, it's just VS Code. You've probably used it if you're here right now, because most people that watch this have used VS Code, but if you haven't, don't worry about it. It's just a one-stop shop for actually handling your code that results into your website. And the tools that can help you do what we call pair programming, which is basically, specifically in this case, I'm using Claude Code, and I can give it natural language instructions, and specifically the lines that I copied from my email. It's going to read this information over here, and then it's going to create a plan of attack to actually address it. And here we are now, like it's going through the plan of attack, since you couldn't access securityheaders.com because that's not authorized if you're not visiting the website physically. And it's going to find what's missing over here. And specifically, you see here, this is where the header policies are defined. And we have policies that address everything else that we did correctly, but we don't have the content security policy or the permissions policy. And now that we do, we're able to actually go ahead and say, yes, I allow this. And, we're done. So now that I push my changes, we're going to go ahead and run again securityheaders.com. So let's go ahead and run again the scan, and we're going to have over here the scan show us that, yes, we passed it. Excellent. And just to be sure here, let's see what our automation says. So I'm going to go ahead and pin the input, which is going to just take the same website. And I'm just going to actually the workflow again from the start. And we should see a new set of results come up here. Great, we passed. There's seemingly something that's still missing here, so I need to check that out. Seems that we have still a usage of insecure security policy. The unsafe inline basically reduces cross-script protections. So think of it as like the malicious scripts that we were talking about earlier. If you were to have somebody wanting to do the injection of a script that can steal your information, that would be an XSS attack. We're going to go ahead and do this once again. Specifically, I said, just by copy pasting, that we want to remove the unsafe inline content security policy. So if we go down here, we'll see it's just a long line that gives a list of websites that are allowed to actually access us. But you can see this over here is something that we do need to address, and we're going to accept that. So that's been caught, and we rescanned and got that A+. So it seems we fulfilled the requirements for having a bulletproof security policy implemented, and we're just going to confirm again with our tool. And we can see our results as well here. Confirm, we got an A+ from our workflow. Email over here shows the same thing, and some preemptive instructions in case you want to use it again to create a master prompt that can be used for the future rollouts, right? So it does that service for you as well. So to wrap it up, we did address our security headers to perfection. But there is more to this actually, because a website is not comprising only of, let's say, the rules related to how you visit that page, but also how you handle the services tied to this website, commonly known as API endpoints, right? When you make a call to an OpenAI inference point, that is an API endpoint, and you need to manage your keys correctly, right? When you want to save information to your database and who gets to access that information, that's about database access. And also when you want to authenticate and authorize somebody to see certain private pages, that set of activities is part of a broader set of checks we have to do for making sure our website is secure.